In this video, we're going to introduce the topic of statistics and go over some basic statistical terms that we'll be using throughout the semester. First of all, what is statistics? If we're talking about the word statistics, the common everyday meaning usually refers to things like numbers, percentages, graphs, and you see this used to support a particular point of view. Many times, statistics are stated without any source cited. In this class, we're going to study statistics as a collection of methods for things like planning studies and experiments, obtaining information, which we'll call data, and organizing, summarizing, presenting, analyzing, and interpreting that data. We'll also talk about making inferences and drawing conclusions. We need to go over some basic terminology. We're going to start with populations and samples, since we'll talk about those a lot in this course. First of all, a population is an entire group of individuals that we want to study. Most of the time, we can't get information for an entire population, so instead of doing that, we look at a sample. A sample is a smaller subset of the population that we're trying to study. In that sample, we have individuals. An individual in statistics is a person or even an object that's a member of the population being studied. Some key concepts about populations, samples, and individuals. If we're taking a poll or a survey, the sample is the set of all of those that are surveyed. The population is always a larger group than the sample. And if the sample is chosen from a group with specific characteristics, then the sample can only represent a population with those same characteristics. For example, if 500 U.S. citizens are surveyed, then the sample is the 500 citizens. The population represented by this sample is only all U.S. citizens, not all people in the U.S. Here's an example. A Nielsen television survey of 4,000 households in the United States finds that 2,988 of them watched the final episode of American Idol. The individuals in this sample are households because the households were what were surveyed, not the actual people in the households. The sample is the 4,000 households that were surveyed. This includes all of those that were surveyed, not just the ones that watched American Idol. And the population represented by this survey is all households in the United States. It doesn't represent households in other countries because there were no households from other countries included in the sample. There are two more terms that we're going to talk about. First, we want to look at the definition of the word statistic in this course. We have the study of statistics overall, which is a different thing, but when we talk about a statistic, we're talking about some kind of numerical measurement describing some characteristic of a sample. So if we have a sample and we get a numerical measurement from that, that always gives us a statistic. The thing to help you remember this is that sample and statistic both start with an S. We also have parameters. The definition of a parameter is that it's a numerical measurement describing some characteristic of a population. This one comes from a population instead of a sample. The way that you can help yourself remember that is that population and parameter both start with P. Here's an example. Suppose the percentage of all students on your campus who have a job is 84.9%. The question is whether this 84.9% would be a statistic or a parameter. The key to this is that this is the percentage of all students on your campus. That would make it a population, and that would make the 84.9% a parameter. Now suppose we have a sample of 250 students, and from this sample we find that 86.4% of the students in the sample have a job. This time the 86.4% would be a statistic because it came from a sample. The fact that we were talking about all students in this first part of the example, that made that a population, and that makes the percentage a parameter. In this case, we had a sample of 250 students. That makes the percentage here a statistic. Another term we're going to use a lot in this course is data. So we want to talk about what data actually means. This would be observations that describe characteristics of an individual. These can be things like measurements, height, weight, genders, survey responses, ratings, or test scores. Those are just a few examples. And when we talk about a data set, that's going to be a table or a list of all the observations obtained for an entire set of individuals. The variables are the different types of observations included in the data set. Each variable has a range or a list of different possible values. A census is a data set that actually contains data for all the individuals in the population. This would be the case where it is possible to get information for the entire population, so we don't actually have to select a smaller sample. We can actually use the data for the entire population. So in that case, instead of a sample, we have a census. An example of this is the United States Census. When they conduct the census, they try very hard to get data for the entire population of the United States. Now we're going to talk about different types of data. First of all, we have quantitative data. Quantitative data gives us the numerical measure of a characteristic of an individual. In other words, it has to be something that's a number. One way that we can tell data is quantitative is if we can do numerical calculations such as addition, subtraction, finding an average, and get meaningful results from this calculation. Here are some examples. The number of students taking math courses at WNCC each semester would be quantitative, and the ages of hospital patients would be quantitative. If we record the age of each patient, that gives us quantitative data. The other type of data is categorical. In some places, you'll see this called qualitative. This type of data gives a classification of an individual based on some attribute or characteristic. The important thing here is that it gives us a classification. In other words, it divides data into categories. These may or may not be numerical values. And to tell that something is categorical instead of quantitative when it's something that's a number, if you try to do numerical calculations with categorical data, they usually don't make sense. Here are some examples. The prefix for a WNCC course, for example, math, chem, speech, etc. Student ID numbers. Even though these are numerical, if you tried to do calculations, for example, finding the average of the student ID numbers, it might give you an answer, but it wouldn't make any sense. Survey responses, such as yes, no, no opinion, and age categories of hospital patients. So instead of recording the age of each patient, if we put them into a category instead, that gives us categorical data instead of quantitative data. Going back to quantitative data, there are actually two types of quantitative data. The first one is continuous. For continuous data, the values could be any real number within a certain range. This would correspond to an interval that you might have talked about in an algebra class. For continuous data, there are no gaps between the possible values. The other type is discrete data. Discrete data can only have specific number values, and there are gaps between the possible values. Discrete data often answers the question, how many? Here's some examples of quantitative data, and we're going to look at each one and decide whether it's discrete or continuous. First of all, the number of students taking math courses at WNCC each semester. Since this one answers the question, how many students take math courses at WNCC each semester, that makes it discrete. The next is the weights of hospital patients. This would be something that would be measured. In general, measured values are continuous. A patient's actual weight could be anything within a range of values. The number that we record is limited by the accuracy of the scale we're using, but the patient's actual weight could be any real number within a certain range. The next one is the amounts of money won or lost by customers at a casino. Now, these amounts, again, can only have specific values. They might be negative if the customer lost money or positive if the customer won money, but there would be gaps between the possible values. For example, I might have won $5.25 or $5.26, but I couldn't have won $5.25.5. So there's a gap between the two possible values there. That means that this is a discrete value. The next one is the amount of time for an athlete to run 100 meters. Again, this would be a measured value, measured by a stopwatch, and this would be continuous. The number that we record would be limited by the accuracy of our stopwatch, but the actual amount of time for the athlete to run the 100 meters could be anything within a certain range of values. The last one is the ages of hospital patients. Technically, this is a discrete value because when someone asks you your age, what you actually give them is the number of years since you were born. In a way, this answers the question, how many? How many years has it been since you were born? So technically, this is a discrete value. There are gaps between the possible values. For example, you might be 25 or 26. But the reason I put a star by this one is because oftentimes the way that we use this type of data is that we use it as a continuous variable. So this is like a lot of other things in statistics. Depends on the situation. It depends on how we're using the information as to how we want to think about it. There are two major types of statistics that we'll talk about. First is descriptive statistics. These consist of ways of organizing and summarizing data. And descriptive statistics describe data through numerical summaries, tables, and graphs. Inferential statistics uses methods that take results from a sample, extend them to the population, and then measure the reliability of the result.